welcome back to part 2 of Solutions, Electrolytes, and Concentration. Part D on page 135, I've pre-populated my form with some data. D1 is the mass of the empty dish, 52.22 grams. We carefully add exactly 10 mils of the saturated saltwater solution. So the volume there is 10.00 mils using a volumetric pipette. Taken together, the water and the dish give us a mass of 64.35 grams. We boil that to dryness, which is the slow, tedious step, kind of like watching paint dry, but if you do it right, it works pretty well. Once it's dry and we reweigh that dish with the dry salt in it now, we got 55.72 grams. So again, those numbers, 52.22, 10, 64.35 grams, 55.72 grams. Okay, the mass of the solution is going to be taken as the difference between the dish that has the 10 mils of solution in it and the empty dish, and that subtraction gives me 12.13 grams. The mass of the dry salt is very similar. We're going to take the dish with the dry salt in it, subtract out the empty dish. I have 3.50 grams. All right, here's where we get picky, and we want to follow the rules that we're hopefully good at. When we have something like this mass percent, we must write down what that means. So mass percent in this context is going to be the mass of the solute over the mass of the solution. Okay, now maybe I'd want to write that as mass of sodium chloride over mass solution or something more specific, but that gets me going and clearly shows that I know what these numbers represent. Okay, I'm going to take the mass of the solute, which was my dry salt, 3.5 grams. I'm going to dissolve that by the mass of the solution, which is my 12.13 grams. To turn it into a percent, I multiply by 100. And hopefully I get what I calculated a couple of minutes ago, 28.9%. D8 is very similar. Now this is a mass volume percent. Very important, again, that I define this. This is mass solute over volume in milliliters of solution. So this will be that same 3.50 grams, but now over 10 ml. So in this case, I have 35% mass volume. Moles of NaCl, this is a gram to mole conversion. So if I have 3.5 grams, do a quick calculation of the sodium chloride, and that is that I have 58.5 grams of NaCl for every 1 mole of NaCl. And that is my 0.0598 moles of NaCl. The volume of solution, properly, I should do another roadmap for this. I'm going to go from mils to liters. Clearly that's taking my 10 ml, multiplying it by 1 liter is 1,000 ml. So I'm going to have 0.0, is that 10? 10 liters. And my molarity takes me back to needing definitions. Molarity is going to be moles of solute. Moles of solute over liters of solution, which conveniently is the previous two numbers we just calculated. So that's going to be my 0.0598 moles of NaCl over 0.01 liters of solution equals 5.98 molar. All right, so again, What's key on all these things is pay attention to writing the units down everywhere, and be absolutely sure every chance you get you write down definitions of any of the terms that are somewhat unique to chemistry before you press on. The final page has some questions. I'll leave them to you to do, but notice that we are just reproducing the lab that we just did. We have a slightly different sample size, but we get the numbers before and after for the solution versus the dry solvent. As with the calculations, we want to see definitions, mass percent, mass volume percent, how we get to the molarity there. Very careful with road maps and definitions. The last two problems are really good ones to work on. It's similar to what we have done in previous exercises of this nature. We absolutely want to take that percent and use that as a conversion factor. So what is that 3%? Well, they tell us it's mass volume, so we want to make sure that we've converted that to useful units. So we'd rewrite that guy as 3 grams of Ki per 100 mils of solution. And then we can use that as a conversion factor to go from whatever we need to. So how many grams of Ki are in 25 mils of Ki solution. So a logical way to do this would be mils of solution to grams of Ki. It's a one-step conversion. All right, the very last one how many milliliters of a 2.5 molar magnesium chloride solution contain 17.5 grams of magnesium chloride? Again, this molar, we want to say, what is that? It's 2.5 moles of MgCl2 per liter of solution. And then hopefully we can put together a roadmap. So how many milliliters contain some number of grams? So our roadmap would almost certainly start with grams, end with milliliters. We have a conversion factor here that has moles and liters in it. So you have to figure out, how do I get from grams to either moles or liters? Hopefully that is fairly obvious. And then the other one would have something to do with going from liters to milliliters. Again, that's something that it's a multi-step. I suppose that'd be 3 steps for our roadmap and ultimately solution. All right, so these are great problems, just straight out of homework type stuff, but applied to the lab. And the important thing with all of this is definitely a focus on what molarity is, but taking every opportunity to write out definitions, whether it's molarity or mass percent things. All right, that's it for now.